My name is Mark Miesch. I work at NOAA's Space Weather Prediction Center through the University of Colorado, and I do computer models of solar storms, of gusts of wind that we call coronal mass ejections that the sun unleashes, and they travel 93 million miles, and some of them impact Earth. So the sun has been doing this for at least thousands of years, as far back as we can determine from various ways. We've been looking at sunspots for about 400 years. So these are dark spots on the sun that you can see. Of course, you don't look at them with your own eyes, but you can look at them with telescopes or special, you might have heard of eclipse glasses. When you look at the sun in this way, you can see spots on the surface. And about 150 years ago, it was discovered that the number of spots kind of comes and goes about every 11 years, so that any individual spot might last a few weeks. But every 11 years, there are a lot more spots than there are in between. So we call this the solar cycle. Along with spots, we now know that spots are really just the first step in a chain reaction. So spots are places where magnetic fields that are created inside the sun pass through the surface. And when they pass through the surface and they get out into the atmosphere of the sun, then they can erupt. They can cause solar storms, different kinds of eruptions. They can send, as I mentioned, these coronal mass ejections. These are gusts of wind, very hot magnetized wind that comes traveling through space. And when it hits the Earth, it squeezes our magnetic field. It wiggles our magnetic field, and that can induce currents in power lines. So the power grid, it can cause problems with the power grid. But also the sun, other types of solar storms can release X-ray radiation and particles, electrons and protons, that can cause problems for satellites. They can disable satellites. And though they don't hurt us here on the ground, if you're an astronaut in space, these particles, electrons and protons, can be dangerous. They can be a health hazard to humans. There's also beauty. So these gusts of magnetized wind or magnetized plasma, hot gas that comes from the sun, when they hit the Earth, they can send streams of particles, electrons and protons. It's mostly the electrons that come near the north and south magnetic poles. When those electrons come in and hit the atmosphere, they make the molecules in the atmosphere glow. So so we can see that those solar storms can create northern lights that we can see here on Earth. And we're coming into a period that we'll see more of them. What is space weather forecasting? So I would say it's a way to give warning to our technological society when the sun is doing something that's going to have an impact on our electronics, on our spacecraft, on our GPS, on our TV reception, satellite reception, telecommunications. Yeah, so I got interested in science when I was in high school. I was interested in physics. I read, my favorite author at the time was Carl Sagan, the astronomer who wrote books about space and astronomy. One of the current torchbearers for Carl Sagan would be Neil deGrasse Tyson, who my son has read and has been very inspired by. So I became interested in science out of curiosity. I wanted to learn how the world and the universe works. But as I got older, I also wanted some service to society. So I spent 25 years doing basic fundamental research into the origins of magnetic fields in the sun and stars. But then I wanted to apply it more to something that was affected people's lives a little more, a more tangible impact on people's lives. So that's when that's something about the interesting about the sun is it's our window to the cosmos. It's our local star. It's a star in our own neighborhood, but it also affects our daily life and our technological society. So space weather forecasting allows me to combine that curiosity about the universe with something that really impacts people's lives.